The Johnstone Supply Company Cafferty Group, with offices in Nebraska, Iowa, Kansas, and Colorado, presents Amana 90 Plus Gas Furnace Installation and Commissioning Training Module TRF32. This training will include product overview, unit placement, horizontal conversion, condensate management, venting, gas valve, wiring and controls, commissioning, temperature rise and adjusting blower speeds, and checking duct static. Product overview. Let's take a look at the nomenclature or model number. The first position is the unit brand, A for Amana. Second position is the configuration, R is upflow, R32, D is downflow, R32. The third position is the motor. V is for variable speed ECM, comfort bridge. 9 is for multi-speed ECM. The next position is for the gas valve. M modulating, S single stage, T two-stage. Next position is for the AFUE or efficiency. The next position is for the BTU rating. The next position is for maximum CFM, 3 ton, 4 ton, 5 ton. The next position is for the cabinet width, 14 inch, 17.5, 21 inch, 24 inch. The next position is for the natural gas rating. The next position is for major revisions. A is initial release, B is first revision. The last position is for minor revisions. A is the initial release, B is a first revision. Furnace controls. Amana offers 2 different thermostats for the gas furnaces. The Amana brand Smart Thermostat for models ARVM97, ADVM97, ARVT96, ADVT96. And we offer the single and 2-stage thermostats for models AR9T96, AD9T96, AR9S96, AD9S96, AR9S92. Communicating 90 plus furnaces. Amana offers the ARVM97, 97% modulating upflow horizontal furnace, and the ARVT96, 96% 2-stage upflow horizontal furnace, the ADVM97, 97% modulating downflow horizontal furnace, and the ADVT96, 96% 2-stage downflow horizontal furnace. For non-communicating 90 plus furnaces, the AR9T96, 96% 2-stage upflow horizontal furnace, AR9S96, 96% single-stage upflow horizontal furnace, and the AR9S92, 92% single-stage upflow horizontal furnace. The AD9T96, 96% 2-stage downflow horizontal furnace, and the AD9S96, 96% single-stage downflow horizontal furnace. R32 compatible furnaces. This furnace may be paired with a cooling unit that uses R32 refrigerant. If the cooling unit paired with this furnace does not use R32, the R32 function in the furnace control board needs to be turned off. Refrigerant systems other than R410A or R32 may require an additional mitigation control board. Refer to the installation manual of the indoor evaporator coil to determine the installation requirements for that supplier's refrigerant detection system. Internal cabinet ID. The door sight glass allows the technician to see the LED display with the door on. Self-diagnostics control board. Factory installed internal condensate trap only on 90% plus models. Gas valve available for 1-stage, 2-stage, and modulating models. durable silicon nitride igniter on all models, fully insulated heat exchanger and blower section, non-communicating printed circuit board. This has more speed taps, 9 speeds cooling, 9 speed circulation, more CFM range, a 3-digit 7-segment LED display, and an A2L sensor plug. Accessories. Refer to the product spec sheet for model-specific accessories. Some of the accessories include 2-inch concentric vent kit, 3-inch concentric vent kit, drain kit, horizontal left vertical flue, external filter rack with a 16 by 25 permanent filter, flush mount vent kit 3-inch or 2-inch, flush mount vent kit 2-inch, fossil fuel dual fuel kit, high altitude natural gas kit, high altitude LP gas kit, horizontal drain tubing kit, low LP gas pressure switch, 2 different LP conversion kits for the different models of furnaces. Comfort Bridge technology on the ARVT ADVT. Comfort Bridge technology smart home algorithm gathers HVAC system performance data and uses it to automatically make adjustments that may reduce the amount of energy used to heat or cool your home. HVAC equipment with Comfort Bridge technology features a communicating circuit board designed to work with many thermostats, such as single-stage or smart home thermostats. After installation and initial startup, the basic temperature functions of the thermostat or HVAC system remain the same. It is Bluetooth enabled and functions with the CoolCloud HVAC application. The CoolCloud HVAC app can see specific model information, review active diagnostic error codes, observe system menu testing and all operational modes, heat, cool, or fan, and directly update furnace software. Non-A2L furnace integration board. Furnaces not compatible with R32 will require a furnace integration kit when pairing an R32 cooling system. Furnace integration kit part number is 0230K00044. Unit placement. Attention installing personnel. Do not lift the furnace using the heat exchanger. Damage to the heat exchanger could result. Positioning. Depending on the model, the furnace can be installed in an upflow, downflow, horizontal left, or horizontal right position. Unit cannot be installed on its back, nor can ductwork be attached to the back. Clearances. 24-inch front clearance required for servicing or cleaning. Unit connections, electrical, flue, and drain, may require greater clearance than the minimum listed below. Adhere to the clearances of combustible materials. For upflow or horizontal installations, if they are to be placed on a combustible floor, the floor must be wood only. For counterflow installations, installation is for non-combustible floors only. A non-combustible subbase must be used for installation on combustible flooring. Upflow. When installing a furnace using an auxiliary drain pan, seal the bottom of the furnace. Use blocks or bricks to elevate the furnace off of the bottom of the pan. Suspension. Suspension from rafters or joists. Use 3/8-inch threaded rod, 2 by 2 by 3/8 angle iron. Crawlspace installation. Suspend from floor joists, supported by a concrete pad, Never install on the ground under a home. It could be exposed to water. Leveling. Level lengthwise from end to end for proper flue pipe drainage. Install the furnace with a slight tilt from the back to the front, with the access doors downhill from the back panel. Tilt approximately 1/2 to 3/4 inches. Air filter locations. Possible upflow locations for the air filter is in the central return air grill or a side return external filter rack kit. Possible downflow locations: a filter access door at the return entrance of the furnace or a central return air grill. Depending on the installation, differing filter arrangements can be applied. Return options. Bottom return. The bottom return air opening on upflow models utilize a lance and cut method to remove the sheet metal from the duct opening in the base pan. Unfold the duct flanges around the perimeter of the opening using a pair of seamer pliers or seamer tongs. Warning: sharp edges. Gloves are required. Return options. Side return opening. On upflow units, guide dimples identify the side return cutout locations. Use a straight edge to scribe lines that will connect the dimples before cutting your opening. Evaporator coil installed on furnace. Rails are provided for installing a larger width coil on the next size smaller furnace width. Ensure the rails are removed when installing coils on identical width furnace cabinets. Here is an example of the bottom of the coil cabinet with the rails installed and the rails removed. Correct is both facing front. Incorrect is anything other than both facing front. Condensate management. Auxiliary drain pan. An auxiliary drain pan must be installed under the furnace if it is being installed over a conditioned space. It must cover the entire area under the furnace. It is secondary containment for a trap. Should be under both furnace and evaporator coil when applicable. Drain trap. Condensate drain trap is secured to the furnace side panels in horizontal applications. A minimum clearance of 5.5 inches below the furnace must be provided for trap installation. The drain trap must be primed prior to furnace startup. Fill both sides of the drain trap with water. Importance of drain trap priming is to ensure proper furnace drainage upon startup, and it prohibits the possibility of flue gases escaping through the drain system. Drain lines. Here is an example of the drain trap exiting the left side of the furnace. Here is an example of the drain trap exiting the right side of the furnace. If a higher drain exit is needed, a 0.875-inch diameter hole may be added to the area shown in the acceptable drain hole area, shown on the diagram on the right. Any unused cabinet opening must be sealed. Do not allow the drain hose to sag or trap water. Check local codes concerning 90-plus furnace condensate drainage. Depending on environmental conditions, pH neutralizer may be required. Drain tubing kits. For horizontal application, make sure to order the horizontal drain kit listed in the accessories chart. Instructions are in the installation manual under Condensate Drain Line and Drain Trap section. The part numbers for the upflow and downflow drain kits are shown on the left. Please note, the drain kits must be requested when ordering the furnace. Venting. Direct or non-direct venting. All furnaces are dual certified and built with a 2-inch vent intake pipe and connectors. Transitioning from 2-inch to 3-inch vent and intake pipe should be done as close to the furnace as possible. Do not connect type B, BW, or L vent or any vent connector that's metal. Cellular core PVC or ABS cannot be used for flue vent. Must not be vented to any portion of a factory-built or masonry chimney, except when used as a pathway for vent piping to pass through. Consult your local inspection department for any local venting requirements. Venting options. Combustion air intake or flue vent options. RF000142 coupling. If condensation is a concern, the RF000142 coupling can be secured directly to the furnace intake or flue vent. If used on a combustion air inlet, it must be installed with the arrow pointing up. The combustion air will be moving in a direction opposite the arrow on the RF000142 coupling. It must have a field-supplied, trapped drain tube, free draining to a proper condensate disposal location. The unused drain should be capped. Direct venting requires both a combination air intake vent flue pipe. Vent piping may be run horizontally and exit through the side of the building, or vertically and exit through the roof of the building. Vent piping may be run through an existing unused chimney. Vent piping must extend a minimum of 12 inches above the top of the chimney. The rubber coupling is installed so that the vent piping can be removed to move the furnace and service the evaporator coil. T's are alternative condensate management options. Vertical venting. For condensate management on a vertical vent, you can use a PVC Y or T as shown in the image. Requires both a combustion air inlet and flue vent pipe. Vent pipe may be run through an existing unused chimney. Vent piping must extend a minimum of 12 inches above the top of the chimney. Non-direct venting. A 90-degree elbow must be medium or long radius. A 90-degree elbow should be attached to the furnace's combustion air intake. The 90-degree elbow will guard against inadvertent blockage of the air intake. Pipe lengths, diameters, and elbows allowed. Refer to the table in each manual for applicable lengths, elbows, and pipe diameter for construction of a vent flue pipe system. Elbows and/or T's used in the terminations must be included when determining the number of elbows in the pipe system. For installations at or above 5,000 feet altitude, use 3-inch pipe. Vent terminations, direct and non-direct. If a 90 or a 45-degree elbow is used for termination, it must be pointed downward. Must terminate at least 3 feet above any forced air inlet located within 10 feet. Non-direct vent termination, at least 4 foot below a window, 4 foot horizontally from a door, window, or gravity air inlet, 1 foot above any door, window, or gravity air inlet into any building. Direct vent terminations. Must terminate at least 12 inches from any opening through which flue gases may enter a building, door, window, or gravity-fed inlet. A vent pipe run vertically through a roof must terminate at least 12 inches above the roof line and be at least 12 inches from any vertical wall. Also may not terminate over a public walkway or any area where condensate or vapor could cause a nuisance or hazard. The combustion air intake termination of a direct vent application should not terminate in an area which is frequently dusty or dirty. Venting options. Alternate vent flue locations, the RF000142 coupling. The RF000142 fitting may also be used as an option to exhaust flue gases for horizontal left installations. The alternate vent flue location is the large hole directly in line with the induced draft blower outlet. Installing the RF000142. Remove the 4 screws from the vent pipe flange on the top of the furnace. Remove the internal elbow and vent pipe. Cut off the pipe 2.5 inches from the flange. Remove the plastic plug from the side of the furnace in line with the inducer outlet. Install the cut end of the vent pipe into the rubber coupling and tighten the hose clamp. Install the 4 screws you removed earlier to secure the flange to the cabinet. Install a drain hose from one of the rubber coupling drains to the drain trap and cap the unused drain. Relocate the front cover pressure switch tube and cap the unused port. Let's look at the gas valve. Gas valve and connections. These furnaces have a 24-volt gas valve controlled by the integrated control module. A manual on-off control is located on the gas valve. The gas piping supplying the furnace must be properly sized based on the gas flow required, specific gravity of the gas, and the length of the run. Here's an example of a natural gas capacity of pipe chart. This can be found in the installation manual. This chart shows the pipe length, the pipe diameter, and the cubic feet per hour of gas capable of passing through that pipe at that length. To calculate the needed cubic feet per hour, take the BTU input of the furnace over the heat value of the gas in BTUs per cubic foot. Gas valve and connections. Gas piping may enter the cabinet from the right or left side. The installer must supply rigid pipe long enough to reach the outside of the cabinet to seal the grommet in the cabinet penetration. A semi-rigid connector to the gas pipe can be used outside the cabinet if allowed by local code. Half-inch NPT pipe and fittings are required. A union may be inside the furnace cabinet if allowed by local codes. Gas piping leak checks. Leak test before placing the unit into operation. Use approved chlorine-free soap and water solution, electronic combustible gas detector, or other approved testing methods. Never use a match or open flames to test for leaks. LP kits available. The single and 2-stage gas valves are field convertible to use with propane gas. For single and 2-stage furnaces, replace the regulator spring or springs with propane gas springs from the appropriate propane conversion kit and replace the orifices. For modulating furnaces, add a jumper to the gas valve for propane conversion and replace orifices. Now let's look at wiring and controls. Electrical connections. Check the furnace data plate before installing electrical connections. Power supply to the furnace must be NEC Class 1 and must comply with all applicable codes. Use a separate fused branch electrical circuit containing the properly sized wire and fuse or circuit breaker. An electrical disconnect must be provided at the furnace location. Furnace must have a copper ground wire connected to the breaker panel. Connect hot, neutral, and ground wires as shown in the wiring diagram located on the unit's blower door. For direct vent applications, the cabinet opening to the junction box must be sealed airtight. Line polarity must be observed when making field connections. Line voltage connections can be made through either the right or left side panel. Checking for line polarity. The hot leg L1 to ground reading should be around 120 volts AC. The common or neutral wire to ground should be 0 volts AC. Electrical grounding. A ground wire should be run from the furnace ground screw located inside the furnace junction box all the way back to the electrical panel. Do not use gas piping as an electrical ground. Confirm proper unit grounding. Ensure electrical power is turned off. Measure resistance between the neutral, typically the white wire, and one of the burners. Resistance should be 2 ohms or less. Metal conduit is not considered an acceptable substitute for an actual ground wire to the unit. Electrical connections. 115-volt line accessories, such as humidifier or electronic air cleaner. Electronic air cleaner, humidifier, and other accessories must be in series with the accessory/zoning control board. Follow the humidifier or air cleaner manufacturer's instructions for locating, mounting, grounding, and controlling these accessories. The Integrated Control Module Single Humidifier Terminal, designated HUM, is energized with 115 volts whenever the inducer draft motor is energized. This terminal can also provide 115 volts to a humidifier transformer if you are installing a humidifier with a 24-volt solenoid. The remaining primary transformer wire would be connected to the line neutral on the control board. The Integrated Control Module Electronic Air Cleaner Terminal, designated EAC, is energized with 115 volts whenever the circulation blower is energized. The accessory load and line voltage specifications are as follows. Both the humidifier and the electronic air cleaner terminals are limited to 1 amp maximum current at 115 volts AC. Here is a diagram showing the accessory/zoning board connections to the integrated control module using the example of humidifier and electronic air cleaner connections. Here's an accessory/zoning board connection example to the integrated control module with the example of a UV light connection. There would be a field-supplied transformer mounted outside of the furnace cabinet. 24-volt thermostat wiring, optional dehumidistat wiring. The optional usage of a dehumidistat allows the furnace's blower to operate at a slightly lower speed, 85% of the desired speed, during a combined thermostat call for cooling and dehumidification call from the dehumidistat. This would be done through an independent dehumidistat or through the thermostat's dehumidification terminal if available. The lower speed of the blower enhances dehumidification of the conditioned air as it passes through the AC coil. A dehumidistat applied to this furnace must operate on 24 volts AC and use a switch that opens on a rise in humidity. Connect the dehumidistat neutral wire to the dehumidification terminal on the integrated control module. Connect the dehumidistat's hot wire to the R terminal on the furnace's integrated control module. Thermostat heating stage selection. A single or a 2-stage heating thermostat can be used to control this furnace. To select which type of thermostat to be used, locate the AHS menu by pressing the left or right menu buttons. Press the center button to enter the AHS menu. Use the left or right buttons to scroll through the available options. NO setting is the default setting for a 2-stage thermostat. 10, 20, 30, and 60 selected values will indicate the number of minutes the unit will run in low-stage heating before changing to high-stage heating. AUT, or automatic timing for the transition to second stage heat, will be calculated by the control board based on the run time of previous heating cycles. Press the center button to select the option. Press the center button again to confirm your selection. Using a single-stage heating thermostat, in auto mode, the transition to second stage heat will vary between 1 and 12 minutes. See the chart below showing the duty time percentage, heat stage timing, and the demand. R32 sensor wire routing. The R32 sensor wire coming from the indoor refrigeration unit or coil will need to be routed into the furnace and connected to the connection point on the furnace control board. The wire should be routed alongside the thermostat wires through the low voltage openings in the left or right side of the furnace blower compartment. Important note: wire routing must not interfere with the circulation blower operation, filter removal, or routine maintenance. Wires should not be routed near hot surfaces and should be protected from sharp edges. Dual fuel applications. This unit can be used in a dual fuel application. A dual fuel application refers to a combined gas furnace and heat pump installation. Strictly follow the wiring guidelines in the dual fuel heat kit installation instructions. The Amana brand smart thermostat. An Amana communicating system is one that includes an Amana communicating gas furnace, air conditioner, or heat pump with an Amana brand smart thermostat. Indoor unit, outdoor unit, and thermostat interact or communicate digitally with each other. Below, you'll see a list of 90+ efficient gas furnaces that are compatible with the Amana brand smart thermostat. Communicating system. Communicating furnace with a non-communicating single-stage AC. 4 wires are required between the furnace and the thermostat. 2 wires are required between the furnace control and the single-stage air conditioner. One of the red keys attached to the plug outlet will need to be removed. Communicating furnace combined with a communicating AC or heat pump. 2 wires are required between the outdoor unit, AC or heat pump, and the gas furnace integrated control module. 4 wires are required between the gas furnace, the cased coil integrated control module, and the Amana brand smart thermostat. Commissioning. The CoolCloud HVAC app, ARVT and ADVT system testing. Download the CoolCloud HVAC app. It is needed to start up and test all operations of both indoor and outdoor units. Please note, with a communicating heat pump installed, it will be treated as a priority heat for a W call. To test gas heat only, disconnect communications between the indoor and outdoor units before running the test. Download for the ARVT, ADVT. Download the CoolCloud HVAC app. Where can you download the app? The CoolCloud HVAC app is available in Apple and Android versions on the Apple App Store or Google Play. Log in. Log in where you have a strong cell signal or are on an available internet network. Create a new account to get started. New users will have to register for an account by providing the registration information. Note: username information cannot be edited once selected by the user. If a user would like to make changes to the account information, a new account will need to be created. Connecting to the indoor equipment. Move to the proximity of the indoor equipment. Boot up the app and the indoor equipment should appear on the device screen. Random Bluetooth equipment in range may also appear, but can simply be ignored. If the equipment you're searching for does not appear, choose Refresh in the upper right corner. Pressing Logout returns the user to the previous login screen. A unit may not show up if it is out of Bluetooth range, another user is connected to the same Bluetooth device, or the unit is not powered on. Tap the desired equipment to begin the connection steps. Pairing methods. Two methods are provided for security verification. 1. Pair by circuit board code. That allows the user to enter the 3-digit code showing on the circuit board's 3 7-segment displays. 2. Pairing using thermostat tasks. This requires the user to complete simple tasks with the thermostat. It can be very useful if the indoor equipment is in an undesirable area and the user wants to obtain information without going to a hot attic or a cold crawl space. Pairing using the printed circuit board code. You will be prompted for a 3-digit code shown on the 3 7-segment displays. If the code is visible, it can be entered into the CoolCloud app in the code entry screen shown on the right. If power must be removed, or if getting the code requires you to eliminate the current diagnostic codes, then pairing the device by thermostat method may be more desirable. This prevents the loss of an active diagnostic code. Pairing thermostat tasks. Perform the thermostat task as instructed by the application. Using the fan for verification eliminates latency caused by the heating-cooling demand delays. The user will be notified when each step has been completed and instructed on what to do next. Once successful, the user will see a success indicator and be moved to the main equipment screen. Software updates. Once paired, available software updates will be displayed. Mandatory updates are required before moving forward. Optional updates can be downloaded or skipped. System Overview Screen. The System Overview screen appears once updates have been completed or skipped. Previous work notes. Notes can be added and viewed in this screen. Notes are stored in the control board. Important notes cannot be deleted or changed after entry. This allows selection of equipment the user wishes to interface with. Communicating outdoor units will appear on the list as an AC or heat pump with the model number displayed. Non-communicating or non-setup outdoor equipment will be shown as unknown. Device Overview Screen. The user can view configuration settings, adjust device settings, view device status, view sensor data, view fault code history, update equipment software, run equipment tests, leave notes, or verify and download shared data. R32 compliant furnace. This furnace is equipped with a control board that is capable of monitoring for R32 refrigerant leaks in the indoor coil. Verify that the R32 sensor is plugged in to the furnace control board before startup, if applicable. If the furnace is not paired with an R32 refrigeration system, the default setting in the furnace control board will need to be changed. If the A2L function is disabled, the furnace control will ignore all A2L sensors. If A2L function is enabled, the furnace will monitor the A2L sensor information. In the case of a refrigerant leak, the furnace control board can shut off the gas heat and turn on the blower fan to mitigate the R32. The A2L function enabled menu. R32 function on the control board is on by default. The R32 function can be disabled through the furnace control by entering the A2L function enabled menu and selecting No. Start with the display showing idle. Press the left or right buttons until the LED displays A2E. Press the center button and the LED will display the selected option, yes or no. Press the left or right button to select one of the two options. Press the center button twice to confirm the option. A2L verification. The A2L verification menu allows the installer to verify if the mitigation mode operates properly. The menu simulates the refrigerant leak process and is only able to be used when there are no active alarms or faults. Perform the A2L verification function for all modes of operation one by one: cooling, heating, constant fan, and idle. Set the thermostat to one of the operation modes and ensure the system is running properly in that mode. Note which mode is being tested. To enter the A2L verification menu, press the left or right button until the LED displays A2U. Press the center button and the LED will display the select option yes or no. Press the left or right button to select one of the two options, and press the center button twice to confirm that option. Once yes is selected, the furnace will do the following: display A2L refrigerant leakage code, EAL, shut down the gas operation, energize the optional ventilation and alarm outputs, run the fan at maximum CFM airflow. It is recommended that you wait for the full 5-minute test to complete and for the system to return to the mode of operation it was in. Verify the system is running properly in the operation mode chosen. Repeat the test using the other HVAC modes if not previously tested. It is extremely important to verify the furnace mitigation mode functions properly for all modes of operation. The control will exit the verification function if the 5-minute timeout expires, an alarm or fault is detected, the user turns off the A2L function verification. The furnace must have 115 volts AC supply properly connected and grounded. Proper polarity must be maintained for correct operation. In addition to the following startup and adjustment items, you can get further information in Operational Checks section of the installation manual. R32 refrigerant leak. If the R32 sensor in the indoor cooling unit detects a specified concentration of R32 refrigerant, the furnace will enter mitigation mode and dilute the refrigerant concentration in case of a leak. In mitigation mode, the furnace will do the following: display A2L refrigerant leakage error code, shut down both heating and cooling operation, energize the optional ventilation and alarm outputs, run the fan at maximum CFM airflow. R32 furnace startup. During furnace startup, the furnace control will identify the connected R32 sensor and will start monitoring the sensor communication. A green LED located next to the sensor connection will indicate if there is communication between the furnace control and the R32 sensor. The LED will be on during the duration of the startup and then will either start blinking or turn off. The blinking LED signifies that communication with the R32 sensor is present. LED off signifies that there is no signal with the R32 sensor. If there are no alarms or faults, the furnace will go into normal heat or cool operation after a warm-up period. The furnace control monitors the R32 sensor once per second. Furnace startup. Gas pressure test, used for field test mode only on the modulating furnace. Allows the gas pressure valve to be checked at 100% firing rate. Using the CoolCloud HVAC menu or the push buttons. Select menu options. Select the gas heat icon. Select GPT. The G looks like a 9 in the display. The control board will force a high-capacity heating demand, 100% at this time. Field test mode used to set 100% gas outlet pressure during startup or service. Inlet supply gas pressure. Natural gas, minimum 4.5 inches of water column, maximum 10 inches of water column. For LP gas, minimum 11 inches of water column, maximum 13 inches of water column. Please note, the left and right buttons are for scrolling through the menu. The center button is for selecting the option. Push the center button a second time to lock the selection. Measuring gas supply pressure. Turn off the gas to the furnace at the gas shutoff valve. Connect an appropriate gas pressure gauge at either the gas valve inlet pressure tap or the gas pipe drip leg. Turn on the gas and operate all the other gas-consuming appliances on the same gas supply line. Measure the gas supply pressure with the burners firing. Supply pressure must be within the range specified on the inlet gas supply pressure table. If supply pressure differs from the table, make the necessary adjustments to the pressure regulator, gas piping size, etc. Turn off the gas furnace, disconnect the manometer. Gas manifold pressure measurement and adjustment with the burners firing. Steps to measure and adjust the manifold pressure. Turn off the gas and the power to the furnace. Attach a manometer hose to the outlet pressure barb on the gas valve. Turn on the gas and power to the furnace. Close the thermostat R to W1 contacts to call for low stage heat. Measure the gas manifold pressure with burners firing. Low pressure regulator adjustment. Remove the regulator cover screw from the low outlet pressure regulator. Turn the plastic adjustment screw clockwise to increase pressure or counterclockwise to decrease pressure. Replace the regulator cover screw. High pressure regulator adjustment. Close the thermostat R and W2 contacts to call for high stage heat. Remove regulator cover screw from the high outlet pressure regulator. Adjust tower and turn screw clockwise to increase pressure or counterclockwise to decrease pressure. Replace the regulator screw. Turn off power and gas to furnace. Gas manifold pressure measurement and adjustment. The manifold gas pressure range for natural gas is low stage 1.6 to 2.2 inches of water column, high stage 3.2 to 3.8 inches of water column. Nominal would be 1.9 low stage, 3.5 inches high stage. For LP, 5.7 inches to 6.3 inches water column for low stage, 9.7 to 10.3 inches for high stage. Nominal would be 6 inches low stage, 10 inches high stage. Startup using the 7-segment display system status. When looking at the control board, the 3 7-segment displays located just above the push buttons will be displaying the system status. System status includes current mode of operation, airflow, the AR9S, AD9S, AR9T, and AD9T models show operating blower speed. The ARVT and ADVT models show actual airflow being delivered by the blower, rounded to the nearest hundreds of CFM. Some operational information and active error codes displayed on the 3/7 segment displays would include 2AC, air conditioner high stage, A12, airflow 1200 CFM, E11, error code 11. Here is some push-button menu navigation. Use the left and right buttons to scroll between menus. Use the center button to select displayed menu when menu code is shown on the 7-segment displays. Current menu option will be displayed. The display will flash while using the left and right buttons to navigate through the available menu options. Use the center button to select the displayed option. Once selected, the display will stop flashing. ARVT and ADVT models require the center button be pressed again to confirm selection and return to the main menu. Control board. The PCB BF301 on an AR9S, AD9S furnace. The PCB BF301 with the 7-segment display and push buttons is the new single-stage R32 compliant circuit board. It offers a total of 9 speeds, which allows for more coil furnace rating combinations. Status codes displayed on the AR9S, AD9S furnace. 7-segment display status code. IDL, the system is idle. FAN, we are running continuous fan. 1AC, the compressor is running in cooling mode, low stage. 2AC, the compressor is running in cooling mode, high stage. GH, which looks like 9H on the display, is for gas heat single-stage control. The examples shown above are from an AR9S, AD9S furnace. The full list of codes can be found in the installation manual. Menu codes. Push-button menu codes. For gas heat menu codes, display makes a G look like a 9. So a description of some of the codes. ERR, active alarm menu. F10, last 10 faults. CR, code release number. RFD, reset to factory default. RSD, blower speed for continuous fan, default is F01. AC1, blower speed for first stage cooling compressor, default is F4. AC2, blower speed for second stage cooling compressor, default is F5. CND, cool on delay, default is 7 seconds. CFD, cool off delay, default is 65 seconds. GAF, blower speed for first stage gas heat, default F01. GND, gas heat on delay, default 30 seconds. GFD, gas heat off delay, default 90 seconds. The AR9S, AD9S examples are shown. For a full list of the menu codes, refer to the installation manual. Heating mode speed selection. To change the main blower speed in heating mode, follow these steps. Press the left or right button until the LED displays GH1 for single-stage heat. Press the center button and the LED will display the current speed. Use the left or right buttons to locate the desired speed. Press the center button to select the desired speed. Press the center button again to confirm your choice. Always consult the heating airflow table to choose from available heating speeds. Heating airflow. In this example, we'll look at the AR9S96 furnace. On this chart, we'll examine external static pressure in inches of water column and its effect on CFM and temperature rise at a specific fan speed. I've highlighted the top line, which shows the ESP ranging from 0.1 to 0.8 inches water column. I've also highlighted the default fan speed for this furnace. You can see how the external static pressure affects the CFM and temperature rise at a specific fan speed. For instance, at the default fan speed, at 0.1 inches of water column static pressure, the CFM is 1079 with a temperature rise of 33 degrees. At 0.5 inches of water column, the CFM is 965 with a temperature rise of 37 degrees. Continuous fan mode speed selection. To change the main blower speed in circulation mode, follow these steps. Press the left or right button until the LED displays FSD. Press the center button and the LED will display the current speed. Use the left or right button to locate the desired speed. Press the center button to select the desired speed. Press the center button again and the LED will display the selected speed. All 9 speeds are available for circulation mode. Cooling mode speed selection. To change the main blower speed in cooling mode, follow these steps. Press the left or right button until the LED displays AC1 for single-stage cooling or AC2 for two-stage cooling. Press the center button and the LED will display the current speed for the selected stage. Use the left and right buttons to locate the desired speed. Press the center button to select the desired speed. Press the center button again and the LED will display the selected speed. All 9 speeds are available for both single and two-stage cooling. Y1, Y2, and continuous fan airflow. In this chart, you'll see that I've again highlighted the external static pressure in inches of water column ranging from 0.1 to 0.8 inches. I've also highlighted the default fan speed showing its relationship to the ESP from 0.1 to 0.8 inches and how it affects the CFM and the watts of power used. Notice how as the ESP goes up, the CFM goes down, and the watts consumed goes up. Control board PCB BF302, two-stage. The PCB BF302 with a 7-segment display is the new R32 compliant board. It offers the total of 9 speeds, which allows for more coil furnace rating combinations. Status codes. Here are some examples of the 7-segment display status codes. IDL means idle. FAN, continuous fan. 1 AC, compressor cooling, low stage. 2 AC, compressor cooling, high stage. G, which looks like a 9, H1, gas heat, low stage. GH2, gas heat, high stage. The examples shown are for the GR9T and the GD9T. Full list is found in the installation manual. Menu codes. Here are some of the push-button menu codes. ERR, active alarm menu. F10, last 10 faults. CR, code release number. RFD, reset to factory default. FSD, blower speed for continuous fan, default F01. AC1, blower speed for first stage compressor cooling, default F04. AC2, blower speed for second stage compressor cooling, default F05. CND, cool on delay, default 7 seconds. CFD, cool off delay, default 65 seconds. GA1, blower speed for the first stage of gas heat, default F01. GA2, blower speed for second stage gas heat, default F02. GND, gas heat on delay, default 30 seconds. GFD, gas heat off delay, default 90 seconds. AHS, automatic heat staging for two-stage heat control, default no. The examples shown are for the AR9T, AD9T. Full list is found in the installation manual. 9-speed taps blower motor in gas furnaces. Heating mode speed selection. To change the main blower speed in heating mode, follow these steps. Press the left or right button until the LED displays GA1 for single-stage heating. Press the center button and the LED will display the selected speed number as F and 2 digits 01 through 04. The control will rotate available speed number every time the left or right buttons are pressed. The table below shows the available speeds for low and high heat mode. When the center button is pressed, whatever speed is displayed at that time will be selected. The control will apply the newly selected speed in the next heating call. Note, always refer to the heating chart to choose from available heating speeds. Fan mode speed selection. To change the main blower speed in circulation mode, follow these steps. Press the left or right button until the LED displays FSD. Press the center button and the LED will display the selected speed number as F and 2 digits 01 through 09. F01 is the default speed for circulation. The control will rotate available speed number every time the left or right buttons are pressed. All 9 speeds are available in circulation mode. When the center button is pressed, the current speed that is displayed will be selected. Press the center button again to confirm that speed selection. Cooling mode speed selection. To change the main blower speed in cooling mode, follow these steps. Press the left or right buttons until the LED displays AC1 for single-stage cooling or AC2 for two-stage cooling. Press the center button and the LED will display the selected speed number as F and 2 digits 01 through 09. The control will rotate available speed number every time the left and right buttons are pressed. All 9 speeds are available for both single and two-stage cooling. When the center button is pressed, the current displayed number will be selected. Press the center button again to confirm that speed selection. Heating mode speed selection. To change the main blower speed in heating mode, follow these steps. Press the left or right button until the LED displays GH1 for low-stage heating or GH2 for high-stage heating. Press the center button and the LED will display the current speed. Use the left or right buttons to locate your desired speed. Press the center button to select that desired speed. Press the center button again to confirm speed selection. Always refer to the heating airflow table to choose the available heating speeds. Heating airflow. The top highlighted line shows external static pressure in inches of water column from point 1 to point 8. The next highlighted section that shows F01 shows the CFM and the temperature rise at different external static pressures for W1 default speed. The next highlighted section is F02, which is the default fan speed for W2. It shows the CFM and the temperature rise at the different static pressures. The recommended temperature rise range for both W1 and W2 are 20 to 50 degrees Fahrenheit. Continuous fan mode speed selection. To change the main blower speed in circulation mode, follow these steps. Press the left or right button until the LED displays FSD. Press the center button and the display will show the current speed. Use the left or right button to locate the desired speed. Press the center button to select that desired speed. Press the center button again, the LED will display the selected speed. All 9 speeds are available for circulation mode. Cooling and continuous airflow. The top highlighted line shows the external static pressure in inches of water column between point 1 and point 8. The next highlighted line shows the default fan speed for Y, Y1, Y2, and G, and shows the CFM and the watts used at the specific ESPs. Cooling mode speed selection. To change the main blower speed in cooling mode, follow these steps. Press the left or right button until the LED displays AC1 for low stage cooling or AC2 for high stage cooling. Press the center button and the LED will display the current speed for the selected stage. Use the left or right button to locate the desired speed. Press the center button to select that desired speed. Press the center button again and the LED will display the selected speed. All 9 speeds are available for first and second stage cooling. Control board PCBKF321 for the ARVT and ADVT96. Comfort Bridge technology. The ARVT and the ADVT96 furnaces utilize Comfort Bridge technology. Can be used with the CoolCloud application. Bluetooth enabled with onboard Bluetooth. Status codes. The 7-segment display status codes include IDL, idle, FAN, continuous fan, AC1, compressor cooling, low stage, AC2, compressor cooling, high stage, HP1, compressor heat, low stage, HP2, compressor heat, high stage, GH1, gas heat, low stage, GH2, gas heat, high stage, DF1, defrost, low stage gas heat, DF2, defrost, high stage gas heat. The ARVT, ADVT with communicating heat pump examples are shown. Full list can be found in the installation manual. Menu codes. Push-button menu codes. CAP, Cooling Airflow Profile Settings. Default is Profile D, shown as 4. CBP, Heat Pump Compressor Lockout Temperature. Default temperature, 45 degrees Fahrenheit. CFS, Comfort Settings Menu. Default 5. CRG, Enable or Disable Inverter Charge Mode. CTF, Cooling Airflow Trim, Default 0%. FSD, Constant Fan Speed as percentage of maximum airflow, Default 25%. GAF, Gas Heat Airflow, percentage of maximum system airflow. GFD, Gas Heat Off Delay, Default 90 seconds. GFD, Gas Heat Fan Off Delay, Default 90 seconds. GND, Gas Heat Fan On Delay, Default 30 seconds. GPT, enables gas heat at 100% for pressure testing. GST, percentage of high stage heating airflow to run during low stage, Default 70%. GTF, Gas Heat Airflow Trim, Default 0%. L6F, view the 6 most recent fault codes and clear all fault codes if desired. LRN, restart communication between the indoor and outdoor unit. ODS, select the number of stages for non-communicating outdoor unit. Default, none. RFD, reset furnace settings to factory default. TGT, select the target time the system will attempt to satisfy the thermostat. TON, indoor airflow for non-communicating outdoor unit. Default 6 tons. These are GRVT, GDVT examples that are shown. For the full list, please consult the installation manual. Setup for a non-communicating outdoor unit and the ARVT, ADVT furnace. Non-communicating outdoor equipment can be set up via the CoolCloud HVAC app. On initial startup, click to set up non-com outdoor will appear in the system overview. Select Click to set up non-com outdoor. This will take you to the device overview menu. In the device overview menu, select device settings. In the device settings menu, there are 5 selectable options. Not set, meaning no outdoor unit installed. That is the factory default. Single stage AC, single stage heat pump, 2-stage AC, 2-stage heat pump. Set up the type and size of the unit. On the device overview screen, click on Device Settings. On the device settings screen, Set Outdoor Unit Type will default as Not Set. Choose the appropriate outdoor unit from the list of choices given. In this case, single-stage heat pump. Then you can click Unit Tonnage to select the correct size. Non-communicating airflow settings. In the chart below, you'll see the tonnage selection along with the corresponding airflow. Airflow setup using the CoolCloud HVAC app. ARVT and ADVT Comfort Bridge models offer an expanded set of adjustments. All settings can be adjusted through the push buttons on the control board or through the CoolCloud HVAC app. Go to the device settings for the indoor unit and select the constant speed airflow multiplier menu. Then choose the airflow percentage desired. Airflow settings with a communicating outdoor unit. Main airflow adjustment is not required. The outdoor unit will determine the appropriate amount of indoor airflow to request. Airflow trims can be made as desired. Cooling airflow profiles for the indoor blower can be changed. Airflow, cooling and heating trim. The cooling and gas heating trim menus are used to adjust the airflow from -10% to +10% in 2% increments. In the Device Settings menu, locate the Trim menu. Choose the desired trim settings from the drop-down menu and press Apply Changes to accept the selection. Airflow cooling profiles. The variable speed circulating motors offer 4 different ramping profiles. Using the chart on the left, choose the correct profile that meets your needs. Profiles may be used to enhance cooling performance and increase comfort levels. Control algorithms. Comfort Bridge 90+ furnaces have 2 different control algorithms which can be used to control equipment staging. Runtime learning automatically adjusts the capacity of the equipment to satisfy the thermostat as close to the selected runtime as possible. Uses runtime of previous cycles to determine capacity. Rate of change adjusts the capacity of the equipment based on real-time changes in return air temperature. Lowers capacity with positive return air temperature progress. Raises capacity with negative return air temperature progress. Factory data reset will not erase algorithm selection or settings. This algorithm does not share data with other system components and must have the algorithm selection and settings reprogrammed if the printed circuit board is replaced. Runtime learning algorithm, communicating system. The system automatically makes adjustments in an attempt to satisfy the thermostat as close to the selected target runtime as possible. Target runtime is adjustable and can be set independently in Comfort Settings menu, CFS. It is generally observed that after a power cycle or mode change, cooling to heating or heating to cooling, the system will run full capacity for the selected mode during the first 2 thermostat calls. Based on the selected target runtime and how long the initial cycles take to satisfy the thermostat, the control algorithm may adjust the system staging on a 2-stage or capacity on an inverter system for the next cycle. If the system cannot satisfy the thermostat within the selected runtime, the algorithm will operate the unit at 100% capacity until the thermostat is satisfied. Actual runtimes may change depending on variations of load throughout the day. Rate of change algorithm. The system automatically makes adjustments based on real-time changes in return air temperature. The rate of change has adjustable settings from 1 to 10, default is 5. 1 is the least aggressive, higher energy efficiency. 10 is the most aggressive, tighter control of space temperature. Initiates heating and cooling staging at 50% demand on first stage. 15-minute duct stabilization timer. Samples return air temperature every 3 minutes. Gradually ramps down to 25% for positive return air progress. gradually ramps up to 100% for negative return air progress. Actual run times may change depending on variations of load throughout the day. Setup control algorithm type. Set the desired control algorithm. Pair with the desired system. On your Bluetooth devices, you'll find the model number of the furnace. Select System Settings. Then select Device Settings. Choose Runtime or Rate of Change algorithms. Select the control algorithm from the Control Algorithm drop-down menu. Select the desired algorithm type, runtime or rate of change. Then press Apply Changes to save your selection. To set up the control algorithm rate of change, set the desired rate of change. Select the target heating or target cooling rate. Set the desired target rate. Press Apply Changes to save your selection. Dual fuel using the CoolCloud HVAC app. In the device settings, select Set Point Satisfy Rate. Select Use Custom Settings in the drop-down menu. Then select and set desired menu options and press Apply Changes. Charging the system manually. For 2-stage units, power cycle the indoor unit for a minimum of 5 minutes. Once powered back on, cycle operation via the thermostat. Proceed with charging during the first 2 cycles for high-stage operation. For low-stage charging, cycle the system a 3rd time. The 3rd cycle will automatically move to low-stage operation. For inverter units, select CRG from the control board menu. This activates high-stage operation for 60 minutes. May be manually disengaged. It automatically exits after 60 minutes. Charging using the CoolCloud HVAC app. On 2-stage units, activate testing mode. High speed 100%, low speed 49%. On inverter units, select active charge mode and turn to on. High stage runs for 60 minutes, then exits. You may also exit manually. Shared data. All communicating units contain shared data. Shared data is equipment-specific parameters programmed at the factory into the equipment. If the model number is visible in the System Overview screen, the equipment includes shared data. The equipment will not operate without the appropriate shared data. View the shared data information by selecting Shared Data from the Device Overview screen. The equipment will verify if the shared data is present and up to date. If not, the app will give the user the option to update the shared data. Addressing shared data issues at a field level is extremely rare. Updating the shared data will reset all previous settings on the equipment. The user will be guided through the setup process and can use their phone's camera to scan the equipment 2D barcode. If the barcode cannot be scanned, the user will be provided the option to enter shared data manually. The equipment will not allow the user to enter incorrect shared data. Once the shared data is loaded, the user will be provided with a success confirmation notification. Here is a startup checklist for a furnace. Please fill in all the information. Here's where you would list the model number and the serial number. In the electrical section, we have line voltage measuring L1 to neutral and neutral to ground. Secondary voltage measuring transformer output voltage and then reading the blower amps. Under blower external static pressure, here's a place for the return air static pressure, supply air static pressure, total external static pressure. Under temperatures, return air temperature, dry bulb and wet bulb, cooling supply air temperature, dry bulb and wet bulb, heating supply air temperature, temperature rise, and the delta T, or the difference between the supply and return temperatures. Gas pressures, inlet gas pressure, inches of water column, gas manifold pressure, low fire, gas manifold pressure, high fire, gas type, natural gas, LP. Additional checks: check wire routing for rubbing, check for kinked pressure switch tubing, check flue elbow for alignment and clamp tightness, check screw tightness on the blower wheel, check factory wiring and wire connections, check the product for proper clearances as noted by installation instructions. And for your convenience, at the bottom of the page, we've included the formula for converting Fahrenheit to Celsius and Celsius to Fahrenheit. Temperature rise and adjusting blower speeds. Temperature rise. Temperature rise must be within the range specified on the unit's rating plate. An incorrect temperature rise may result in condensing or overheating of the heat exchanger. An airflow and temperature rise table is provided in the specification sheet applicable to your model. Determine the temperature rise from furnace data plate and conduct the following steps to adjust to the correct temperature rise. Temperature rise test is a great way to determine the health of a furnace and the duct system. Operate the furnace with burners firing on high for approximately 10 minutes. Place thermometers in the return and supply air ducts as close to the furnace as possible. Thermometers must not be influenced by radiant heat from the heat exchanger. The cross-hatched area of the picture indicates areas influenced by radiant heat. Subtract the return air temperature from the supply air temperature to determine the air temperature rise. The temperature rise should be within the rating on the unit's data plate. Adjusting the blower speeds on a non-communicating furnace. The installation manual provides an airflow table showing the relationship between airflow in CFM, watts, and external static pressure for the proper selection of heating and cooling speeds. Adjust blower speeds to match your install requirements and provide the correct heating temperature rise and cooling CFM. Decreasing the blower speed will increase temperature rise. Increasing the blower speed will decrease temperature rise. Refer to the chart for the correct CFM and temperature rise at the applicable external static pressure. Temperature rise range should be 25 to 55 degrees Fahrenheit. Checking duct static. Refer to the furnace's rating plate for the maximum ESP, or external duct static rating. Too much external static pressure can result in insufficient airflow that can cause excessive temperature rise. This can cause limit switch tripping and heat exchanger failure. The positive static reading is taken at the furnace supply outlet and must be read between the furnace and the cooling coil. The furnace negative static reading is taken at the furnace return duct inlet and must be read between the furnace and the air filter. Take duct static readings through test holes in the ducts and tape up the holes once the test is complete. Steps to determine total external static pressure. Inspect and/or replace the air filter in the furnace. Install a manometer or magnehelic into the return air duct of the furnace closest to the blower but downstream of the filter. Measure the negative static pressure of the return duct at the inlet of the furnace. Measure the positive static pressure of the supply duct at the outlet of the furnace. Again, measure the positive static pressure of the supply duct at the outlet of the furnace. Measure the negative static pressure of the return duct at the inlet of the furnace. Total static examples: negative static pressure, negative 0.4 inches of water column. Positive static pressure, 0.2 inches of water column. Total external static pressure would be 0.6 inches water column. Ignore the positive and negative sign and add the two numbers together. Thank you for joining us for the Amana 90-plus gas furnace installation and commissioning training module, TRF32. If you'd have any questions or need more information, please contact your local Johnstone Supply Company Cafferty Group office.